Hello, this is Tuna Melt by James Sinclair, part of his Artisanal Sudoku volume 113. It is quite simply a killer Sudoku, so yeah, let's look at the rules of this puzzle. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. All clues are standard, so killer cages mean that the sum of digits inside each cage is equal to the number in the corner. For example, those 2 digits sum to 8 because the cage says 8. Those 3 digits sum to 22 and so on. And obviously in each of these cages, digits may not repeat because they're all in the same box or in the same row or in the same column. But that is also a rule in killer where even if your cage looks like that, digits may not repeat in cages. Alright, so those are all the rules. With that, let us begin solving. Now obviously, well not obviously maybe, but the first thing I see is this central box here with every cell except for this middle one being occupied by a cage. This is useful because it tells us what cell this is. And the reason why is because, let's say at the end of the puzzle, your box here will have the digits 1 to 9, right? And those digits sum to a total of 45. If you add the digits 1 to 9, you get 45. Now we already know what those sum to. Each of these cages sum to a certain number, and therefore we know what all 8 of those cells sum to by just adding up the sums shown here. Then we can take away those 8 cells, and that will give us the final cell. So those digits sum to, well, those who sum to 20 because they're 9, 11. 7 and 14 sum to 21. So those in total sum to 41, meaning that digit is 45 minus 41, which is a 4. Alright, that would help us. We can also look at other cages, like the 3s and the 17s. Those are all very extreme in that the 3 cages must have 1 and 2 in them. That is the only way to make 3 and 2 cells. 17s must have 8 and 9 in them. Those are the only ways you can make 17 and 2 cells. The 8s here and the 22 accompanying are also very constrained because this 8 cage must have a 1 in it. Without a 1, the minimum you can have in a cage would then be 2, 3, and 4, which adds up to at least 9, which doesn't work. So we need 1 in the 8 cage. And similarly, the 22 needs a 9 in it, because without it, the minimum or the maximum you can have the cage sum to is 876, which is 21, which doesn't work. So you need a 9 in the 22 cage and a 1 in the 8 cage. I do see that forms a number of interesting interactions between the 3 cage here. So yes, in this column, where does 1 go? 1, because of this cage, can't be in the box here. Because of this 1, 2 pair, can't be in the box here. So the only place 1 can go in this column is there. And similarly, no, we can't do that. We can do that here though. Where does 9 go? In this column. 9 can't go here or there. 9 must go here. And I'm starting to see a pretty interesting pattern regarding like X windmill, where every rotationally symmetrical cell appears to sum to 10. I mean, it clearly isn't here because of the 7 and 14 cage don't add to 20, but I think that's considered meta-analysis and we should stop doing that. Okay, what else do we have? I mean, I can say yes, that 8 and 9 actually can't be in the 9 cage, in the 8 cage in fact, because 9 can't be in the 8 cage, and that's more important because 9 is already bigger than 8. So how do you have 3 numbers summing to 8 when one of them is 9? That's not possible. So 9 is not in the 8 cage. Those digits therefore block 9 from being in any of those cells. 9 can't be the 8 cage. 9 in this box must therefore be here. Okay. What does that tell us? Well, that kind of tells us that 9 in this box is in one of those cells. It could be in the 12 cage if it's accompanying 3, but the 8-9 pair here removes 9 from that cell. So in fact, 9 in this box must be here. Cool. You can probably do the same for the 1s on the other side. Like 1s can't be in the 22 cage because the remaining digits have to sum to... the remaining digits can only sum to at most a 17. And so with a 1 there, those digits are going to sum to at most 18, which doesn't work. So 1 can't be in this cage, it can't be in those cells because of the 1s here. So 1 is in this box, has to be there. In this box now, can't be here or in any of those columns, so must be here. Cool. Now, what else can we do? I suppose we can say the same thing about 8 in the cage, right? Like 8 can't be in its own cage because the other two numbers can't be 0. So 8 can't be in its own cage. This 8-9 pair removes 8 from those cells, giving us 8 in one of those two cells. And that could help. Except I don't think it does. Yeah, no, it doesn't really look like it does. Okay. I mean, there's a bunch more stuff we can do. All of these cages seem to do stuff, although I can't really see what they do. I mean, I suppose that 9 is in one of those cells, and if 9 was in there, it must be accompanied. If 9 was in the 11 cage, it must be accompanied by 2, right? Because 9 with 2 makes 11. I mean, that is possible if this was a 1. Yeah. Yeah, alright. No idea. Could probably say the same thing about here, maybe? Where 2 can't be in this cage. Because 2 with 8 and 9. Actually, no. Actually, those digits are really quite big. Yeah, there are only 2 ways to make 22 in 3 cages, right? 3 cells, sorry. There are only 2 ways to do it. It's either 9, 8, and then 6. No, 9, 8 on 5. Or 9, 7, and 6. Yeah, those are the only 2 ways. Meaning 1, 2, 3, and 4 are all not in the cage. 2, because of those cells, can't be there, so 2 must be one of those cells. 3 and 4 can be anywhere in those 5 cells though. I don't think it really does anything for us. Okay. Does this 2 do anything? Yeah, I suppose it does, because 2 in this box must not be one of those cells. Or I suppose, yeah, that does lead to the same conclusion, but more simply speaking, where does 2 go in this column? It can't go in those cells, it must go in one of those cells. Meaning that 2 cannot be in the 8 cage. And therefore, because 2 is not in the 8 cage, the minimum we can have in the 8 cage is 1, 3, and 4, which do in fact add up to exactly 8. So they must be 1, 3, and 4. Another way to have said that is because 2 is in one of those cells that forms some sort of X-wing here which looks down in the cage. But that is quite complicated, and so doesn't really do anything for us. I guess we can also now say where does 8 go in this box. 8 has been one of those cells because in this column, 8 come in those 3 cells. So 8 is one of those cells. Therefore, the 22 cage, now without an 8, has a maximum of 9, 7, and 6, which do in fact add up to exactly 22. So they must be 6, 7, and 9. Cool. Sorry. Well, I suppose 8 in this box is now in one of those 3 cells. The thing is that it could be beside a 4 though, so it could be in the 12 cage. What else do we have? Does this help us? If 9 was in here, it must be with 2, but you could also have 2 here and here to resolve that. I think that's fine. 2 here is fine as well. Sorry, I'm blanking out on stuff. 9 in this box? Well, because of an 8, 9 pair and a 9 here, yeah, those digits must have a 9 in there somewhere, and it can't be here. It can't be in the 11 cage because a 9 in the 11 cage must be with 2, but 2 is already in the row. So it can't be in the 11 cage, it must be in the 14 cage, accompanied by a 5. Cool, I could probably do the same with 1s maybe? Yes, where does 1 go in this box? It can't go in those cells because of the 1s looking at it. 1 can't be in the 9 cage because 1 will have to be accompanying 8, which is already in the row. So 1 has to be here in the 7 cage, accompanied by 6. And so now we are missing... Well, 2 must not be in the 11 cage, it must be in the 9 cage, and therefore accompany 7. Well, the last two digits are 3 and 8, which do sum to 11. Cool. Now... what? Oh, I'm sorry, 2 in this box is very easy because those 2's here look at all of those cells, so 2 must be here, that's just it. That puts a 2 in this box. This cell, sorry. And does something. I could also say where 8 goes in this box. Yeah, because of the 8's in those cells, those cells can't be 8. 8 must go here, resolving an 8 there. This does feel very symmetrical, even though it's not entirely. Like if you look at the cells here, right, those don't sum to 10. Even though, you know, those have a high probability of summing to 10. I can't be entirely sure, but it could sum to 10. Alright, what else do we have? I mean, those digits we can place, or we can pair them. They are 3 and 7 to finish the row. Does that do anything for us? No, it doesn't look like we can resolve them either. Maybe this 9 and 8 resolve this 12 cage though, because 12 is only made with 3 possible ways. It's either 9-3, 8-4, or 5-7, but it can't be 9-3 or 8-4 because those are already in the column, so it must be 7 with 5. Which, quite unfortunately, does not affect this. I suppose though that means that we can put a 6 in this column. It must be in one of those cells somewhere, because it can't be anywhere else. What does that mean for this row maybe? 6 can't be in that cell or those cells because of the 6 in one of those cells. 6 can't be there, so 6 is now in one of those cells, which could be useful. I mean, it might affect the 8 or the 10 clue. And we could probably do the same thing with like 4s on the other side. Yeah, like this 7 cage can't be 1, 6, or 2, 5. It must therefore be 3 and 4. Oh, that's resolvable. All of these are resolvable. The 3 here resolves that. The 7 here resolves this 5-7 pair. Yeah, okay, that really helps. It does not resolve this though. That still remains. What does 5 go in this column, I guess? It must be one of those cells. But that doesn't form any more problem. It doesn't form anything with that. So I guess that's where we deviate from the symmetrical route. I suppose in this box, 3 can't be in those cells because of the 3-8 pair here. 3 must be in one of those cells. Which now looks at this box and says, where does 3 go? 3 can't be in those cells, 3 must be there. Could we do the same thing here with 7s? Yeah, 7's in one of those cells because 7 can't be there because of the 2-7 pair. That means that 7 in this box must just be here. Alright, now what? I mean, this was also a triple, isn't it? 3, 4, and 6 to form that triple. And this is also a triple of 5, 6, and 7. Yeah, it doesn't really help us with anything though. I guess the 5 here means this can't be 5. Or the 4 here means this can't be 4. Yeah, that's probably good. Oh, so where does 4 go in this column? Because of 1, 3, 4 here, 4 can't be in those cells. Those cells don't have any 4 in them, so 4 must go there. Can I do the same thing here with like 6 or something? No, because 6 could be there as well. What about... No. Alright, something tells me I may have made a mistake here because this doesn't crawl over to here. 5s maybe? Yeah, well I suppose 5 in this box must be one of those cells. In fact, that forms a triple, doesn't it? That's like 4, 5, 8. Which means this cell now can't be a 5. And so 5 in this box must just be here. Sure, we can see that, yes. Now what? Well, I suppose this 9 now tells us that in this box, 9 can only go in those 2 cells, which means 9 must be paired of 2 to make 11. That means this is a 1, that's a 2. This 1 now is removed from those cells, which means it's there, which now resolves this 1-2 pair. Those cells are no longer 2. In fact, this forms a triple. I think they are 3, 4, and 6. And can we do the same on the opposite side with the 8 and 9? Maybe the 1 here. Yes, the 1 here, because of those cells, must be down there with 7 to make 8. Which doesn't affect this, but it removes 7 from those cells. So now 7 goes here. A 6-9 pair, nice. Removes 9 from that cell, so that's 8. That's nice. That's 9. Did I say nice? I don't know what I'm doing anymore. Okay. What do we have now? Oh, we're getting close to opening this puzzle up. Well, I'm not entirely sure. 6-9 pair, remove 6 from that cell. So 6 in this column must be here. Just seeing if there's anything that I missed. 6 in one of those cells. Well, in this box, this forms a triple. They have to be 2, 5, 6, I believe. 2, 5, 6, which removes 6 from that cell. So that's 7, that's 3, that's 6. Meaning that's 3, that's 7, that's 6. Awesome. Alright. Now what? Well, 2-9 pair here removes 2 from that cell. That's easy. In fact, this 2 also does that. So 2 can't be here, 2 must be there. Which means what? Interesting. Okay. I guess 8, 9 here. This is a 5, 6, 8, 9 quadruple. Doesn't really tell us much though, because yeah, I usually prefer not to do anything quadruples and above, unless it's like, you know, special enough for it to happen. If you can solve a puzzle using quadruples only, I'm gonna assume that's not intended. Triples are as high as I want to go. Okay, we could probably do something else. This 10 cage, yes, we know it's now a 2 and 8. Because it can't be 1, 7, it can't be 1, 9, 3, 7, or 4, 6, those are all in the row. It must be made of 2 and 8. Which, can we resolve that? I don't see how at first glance, so no. Maybe there is a way. I am not seeing it though. Well, this 2, 8 removes 8 from that cell, which is good, because 8 is now forced into here. 2, 8 means this can't be 2, so that forces a 2 up there. This is a 3, 4, 5 triple, awesome. And this is also a 3, 4, 5 triple, nice. In fact, those 3 cells are also 3, 4, and 5. And those 4 cells are 3, 4, 5, and 6. Which is good, because now that cell's a 3, 4, or 5, because it can't be 6. Which does give us a 3, 4, 5 triple right here. Those digits are there for 6 and 9, nice. Which we can resolve actually because of the 9 down there. This 3, 4, 5 also removes 3 from that cell, which gives us 8 here, doesn't do anything. Wow, it really doesn't. Now this forms a triple, they have to be 2, 9, and 7. Wait a minute, no. Something's wrong, this can't be 2, 7, or 9. What did I do wrong there? I probably did something wrong with assuming this. Yes, we got the 3 here. This is not 3, 4, or 5. Oopsies. But in fact, we do know 3 is in one of those cells, at the very least, which gives us a lot of stuff to do. This now still can't be 3. Which does something for us, maybe. In fact, this forms a 4, 5, 6, 9 triple. Which doesn't do much, I don't think. But I guess it's good to know. It's good to know it's there. Oh no, maybe this 13 cage can help. I mean, we know it can't be a 5, 9. But a 4, 9, but it could still be 5, 8, or 6, 7. Unless I'm somehow not seeing why. Yeah, it could be both, I think. It's the last killer cage we haven't resolved yet. Yeah, I'm sorry this is taking a while. This shouldn't be that tough. This should not be that tough, but unfortunately, I am not very good at reading these. I mean, I guess where does 3 go in this box? It must be one of those cells, because 3 can't be in those cells by this 3 here. It can't be in the 3 cage, otherwise you need a pair of 10. In fact, this 3, 4 pair means that is not 3, so 3 must go there. What does that do for us? Nothing. Nothing, okay. Oh, that's interesting. Yeah, in fact, this actually can't be a 5-8. And that is because, where does 5 go in this row? It must be in one of those 3. And in fact, it must be in one of those 2 cells. Because of the 5 here and the 5 here. Which means now it cannot be in the 13 cage. It must therefore not be 4, 9 or 5, 8. It is therefore 6 and 7. Which resolves this 5, 6 pair. This 5 places a 5 there. This 6, 7 pair gives us a final pair here of 4 and 8, which is resolvable. 8. For this 8 resolves all of this stuff at the top. And those last 2 digits are 7 and 6, which is also resolvable. Nice. That digit is just free. It's an 8, I think, which resolves everything. Alright. Cool. 2 now resolves that. 7 now resolves the one on top, which resolves the one down here. 7. And this 2 resolves this 2, 9 pair. Cool. Now, I suppose 9 in this row, because of those 9s, come in those cells and must therefore be there. This forms a 4, 5, 6 triple. The 4, 5, well, the 4, 6 here means that it must be 5. This can't be 6, so it must be 4. 6 goes here. And so now, 5 coming in that cell, 5 must be here. Giving us 2 digits, which are 1 and 4. Yep. Then we can probably just resolve the rest of this. This 4 means it's a 3. Yep, there we go. 4 here, 3 here, 3 in the corner. Very nice. 4 means this has to be 5, this has to be 4. This last digit is a 5. Oh, we have the last one here. This 3 resolves that. Alright, that solves the puzzle in 20 minutes and 56 seconds. A fairly slow start, but hopefully the next few puzzles will be slightly better. Alright, I hope you enjoyed this video. I'll see you guys next time. Bye bye. Hello, this is Exposition by James Sinclair, part of his Artisanal Sudoku volume 113. It is a puzzle consisting of X clues and thermometers, so let's look at the rules. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. All clues are standard, so thermometers mean that digits along a thermometer must increase from the bulb. So a sequence that looks like this would be okay, because every digit is greater than the previous one. Yeah, and this branching thermometer means basically, you know, how do I find, you know, this sort of thing works basically. Obviously, this is the wrong arrangement of digits along the thermometer, but it's just an example. Alright, so those are thermometers. We also have cells separated by X. So those 2 cells, for example, sum to 10, and that is true for every set over here. Those sum to 10, those sum to 10, those sum to 10. Alright, and I also assume that not all X's are given, so any other pair like those could sum to 10 if they wanted to be. Alright, with that, let us begin solving. Now I do notice this middle box first. It's generally where James Sinclair likes to start his puzzles, in the middle box. Like most of the time, the first deduction comes in the middle box, most of the time. And I can tell you where 1 goes in the middle box. It must go there, because all of those digits have at least 1 other digit below it. So 1 cannot be in any of those cells because there is nothing below 1. So 1 must go here, and because of the X is accompanied by 9. Now this makes sense because you know, 9 also can't be anywhere else in the box. 9 has to be at the end of a thermometer if it is on a thermometer, and that is because there is nothing greater than 9. Right, okay. So what are those? I mean, those could be 4, 6, 2, 8, 3, 7. I think any of them would work. I guess the question is, where does 5 go on this box? It must be along this thermal. Alright, and I guess this digit is always less than 4, because it's always 2, 8, 3, 7, or 4, 6. Oh, wait a minute. Yeah, only 1 digit is below 5 here. And same, only 1 digit is above 5 here. So actually along this digit, along this line, we can say that 5 goes in the middle. Because in a box, you always have 5 lows and 5 highs. And by low, I mean digits that are lower than 5. And by high, I mean digits that are higher than 5. There are only ever 4 of each type. because this is always going to be a low digit, because, yeah, and that's always going to be a high digit. We can therefore say that this is also a low digit, that is also a high digit. Now here, the lower digits must be lower than 5, and the high digits must be higher than 5. So along this final stretch, the 5 has to be above 2 low digits and below 2 high digits, meaning it must be right in the center. And I guess it is pretty interesting that x is used as a clue here, because x always contains 1 on each side. If you think about it, the 4 possible options for 10 are 1, 9, 2, 8, 3, 7, and 4, 6. And every one of those options will contain 1 low and 1 high digit. And another thing we can say is that x cannot contain a 5, because you would then need 2 5s to make 10, and that would cause it to be repeated in the row or column. So in this box, 5 can't be any of those cells, it can't be next to an x, it must be one of those cells. Similarly, in here, 5 can't be there, 5 can't be next to x, so 5 is one of those cells. And now in this box, well, 5 is one of those 4 cells. But I'm not sure what that really tells us. Okay, this thermal is 7 long, which makes me a bit tempted to pencil mark it. Because 7 long thermals are things that I am okay with pencil marking. If it's 6 or shorter, I stop pencil marking them, because every cell begins to have like 4 options or more, which is really bad. So let's talk about how we can pencil mark these thermals. The minimum you can have on this thermal is the digits 1 to 7 in order. That is the smallest possible way to fill up this thermal. The biggest is to start from 9 at the top and decrease by 1 every single time to get the digits 3 to 9. And therefore, every digit, the first digit is always between 1 and 3. It's always either 1 to 7 or 3 to 9, or between that. Which means that we can also fill in everything else by adding exactly 1 to each possible digit. Like so. And we can do the exact same here, but actually because 1 is removed from that cell, we can actually remove 1 from there. This is now 2 or 3. And this could technically be a 2, 3, or 4, but because this is 2 or 3, this must be at least greater than 2. So it can't be 2, it can only be 3 and 4. We can use that logic and continue on by doing all of this. And now we have this going on. This is a much neater thermal than this. So that's cool. Okay. Well, what's interesting about those digits, I think, yeah, in fact, a bigger deduction I can make is that those 4 digits are all different. Those 8 digits, sorry, they're all different. And how will I notice that? Is take a look at this 1 here. What do we notice about the 1? Well, the 1 here implies that this cannot be 1 or 9, because 1, 9 implies that, you repeat 1 in this column somewhere. Similarly, because of this 9, this cannot be 1 or 9, right? And those can't be 1 or 9 because they're in the same box. So this is the only x where you can have 1, 9. Similarly for this, whatever combination it is, this digit cannot be in there, this digit cannot be in there. And so none of those are of the same type as this set. And obviously this is not the same as that. And if you keep going this way, you can therefore say that all 4 of these are different sets of things that sum to 10. And what that means is that therefore they have to be the 4 different ways to sum to 10, which are 8 different digits. And I suppose the same thing also applies here, where, because these are 4 sets of the digits that sum to 10, they are also 8 distinct digits. Now I don't know how useful that would be, but maybe that helps us or something. Maybe. Well, because those are low digits, I can just mark them as 2, 3, 4 first, and those are high digits, I can mark them as 6, 7, 8 first. I can therefore mark this digit as because it is, I see. Right, I got it. Because it is, these 2 digits are different, the maximum I can make them be is 3 and 4. And this digit has to be less than whichever the lowest one is here. So this digit is actually at most a 2, sorry. Because if it was 3, you would force both of these to be 4, which doesn't work. This is not the same though, this could be 7, 8, or 9. Because it is only touching 1 cell. Oh, although 2 isn't here, right? So 2 is on the thermal, so this must be less than that. Right, and therefore this has to just be 1. And similarly, because 2 is on the thermal, it can't be here because there's nothing between 1 and 2. So 2 can't be there. 2 is in one of those two cells. Can I say the same for 6? 6 can't be here, yeah, because there's nothing between 5 and 6. And I guess 7 therefore can't be there. And in fact, this can't be 8 because there's nothing here that's greater than 8. So there you go. We have decreases. This can't be 4 for the exact same reason, where this cannot be greater than 4. This 1 here means that's not a 1, and now we get our first useful deduction where this forms a 2-3 pair, so this cannot be 3, it is now just a 4. Since this can't be 4, this cannot be 6, because 6 we need 4 to sum to 10. Aha! And now, because of the initial deduction where we said those contain the 8 distinct digits that could possibly sum to 10, where does the 4-6 pair go? We know it's not here, we know it's not there. This 4 removes 4-6 from here, and so the 4-6 pair must be here. Oh, that is actually really cool. Could probably do the same thing up here though. Right, there's a 7-8 pair here, so this digit must now be 6. And now, well, I guess now 6 must be in one of those cells. But since 6 can't be here, 6 is in one of those cells. 4 is therefore in one of those cells accompanying 6 to make 10. Okay, 2-3 here acts as this 2-3 here, so we can do the same thing and remove the first digit of each of these candidates. Not like that. Like this. There you go. Oh, 8-9 pair here. Didn't see that. So that's now a 7, meaning that's an 8. Which must be next to 2, which means that's 3. And because those digits are a 4th set, they can't be any of those digits. They must be 3 and 7. Ooh, okay. That is very cool. Now we could probably do that somewhere else. This 3 resolves this entire set. No, it doesn't. No, it just means that's a 2. But because this doesn't have to be immediately above 2, it could be still be 4. Yeah. It could still be 4. Okay. Well, I suppose 8 can be in one of those 3 cells. It can't be next to the 2. It can't be next to the X because it would need a 2 beside it. Oh, and I guess we already know those are 8 distinct digits. So if this is 1, 9, and 2, 8, this must be 4, 6, and 3, 7. Yeah. 3, 4, 7, 6. And we already know 6 is in one of those cells. So 4 is in one of those cells. And because of this 7, we now know 7 is not here. And therefore 3 is not down there. So there you go, even more pairs. Now we can probably do something else, like saying where does 1 go in this box? Because of this 1 and this 1, 1 must be here, which pushes 5 upwards. This gives us an 8-9 pair down here. And gives us another pair down here as a result. They have to be 6 and 7. Now that does form a pair with that, which could be useful. Although I guess more useful is where does 1 go in this box? Because of this 1 here, 1 must be one of those cells. Yeah. Okay. 3, 6 pair here removes 3 from that cell, so that's also a 2. Which is not helpful, unfortunately. I guess we can fill in more pairs, like this has to be 4 and 8. While those 3 digits have to be 3, 5, and 9. Does that give us any pairs here, or any triples of some sort? No, I don't see anything. Okay. Well, there's very likely more stuff we can do even though I'm not seeing anything. For example, that's a quadruple right there. Those must contain the digits 3, 4, 5, and 6, meaning this digit now cannot be a 4. I don't know if that's intended. But I'm just going to assume it is, because those are 4 different digits containing 3, 4, 5, or 6. They must contain exactly 3, 4, 5, and 6, meaning that no other cell in this entire column can be 3, 4, 5, or 6. This is now a 7, which resolves all of these, and because of the X gives us all of those digits. This 3 now resolves this entire thermal. Because we're on the higher end now, we must have everything be pushed to a maximum. This 8 resolves this 8-9 pair. This 9 resolves this 8. And we are actually cooking, I think. Cool. What else do we have? What digit is in here? 8. 8 in this box. Because of those 8s can't be there, so 8 must be here, meaning 5 is in here. Those digits have to be 1 and 2, meaning those digits... Well, firstly this 8 forces a 9 up there, but those digits are now 3 and 4, which does not form any sort of relation to those digits, even though I wish they would. I mean, I'm sure they do somehow. Right, this 7 and this 6 resolves all of this. So this is now 3, sorry. It is not 7, this is not 6. So that gives us that. Those form a triple, they have to be 1, 2, and 5. 2 here removes 2 from there. Actually, because of the 1 in one of those cells and the 1 in here, those cells can't be 1. So 1 goes here. Right, does that help? Maybe. Like, okay, this is a pair, they have to be 5 and 7, and therefore this is a triple which has to be 1, 2, and 6. Now, I don't expect this to help me at all, so no. There's a 6, 7 pair here, that's really suspicious. Is it? Is it suspicious? I don't know. Although I do know that those sum to 10, what is not in this box? What is not in those cells specifically? 1, 2, and 9 are not in those cells. So 1, 2, and 9 must appear here. Which I guess is interesting. If 1 is up here, it can be with 9. But if 2 was up here, that is more interesting because that would have to be with 8. And force all of this on the lower end. I don't see how you can force that to be the case though. So let's just keep doing Sudoku. Those digits form a triple. They have to be 1, 8, and 9. And hopefully this disambiguates stuff. No, I don't really see it doing that. Yeah, this entire top section is pretty empty right now. I mean, well, we're done with most of the clues though. Like, these 2 clues are the only ones we haven't figured out yet. The rest are all resolved. So it's either that I'm missing some regular Sudoku, or something's up with these clues that I'm not seeing. Maybe a hidden pair somewhere. 3, 4 pair here. Yeah, I could also focus on Sudoku. That's also possible. Not really. 6, 7 with 3, 4, 5. 6 is not a quadruple. 6, 7 here. Does that help? I mean, I see. Okay, it tells us where the 6, 7 go in this box. Because of 6, 7 here and the 6, 7 pair up here, none of those cells are 6 or 7. Therefore, in this box, 6 and 7 must be in here. Meaning, there is now a pair of 6 and 7 up there. This is no longer 6. So that resolves everything. This is all falls into the downward area. This can't be 3 or 5 anymore. So that's 9. I see. And that digit is just an 8 to finish the column. Those digits form a triple. They have to be 3, 4, and 9. That digit can be 4. This looks very suspicious. Although I don't really think it is. I suppose 1 is in up there, but I don't think there's anything else we can do. 6, 7 pair. Doesn't do anything to this box. No. Yeah, this 4 resolves this pair here. Does that do anything up here? I don't think so. I guess let's just put a 4 in this box because of these 4s, they have to be here. And we haven't figured out 3 yet though. 3 could be in any of those 2 cells. Yeah. Six maybe? 6 is in one of those cells. Not really though. 7? Oh yeah, 6 and 7. In this box, 6 and 7 must be here. That forms another pair. So those digits are its own triple. They have to be 2, 3, and 5. Now, because of the 3s, none of those cells can be 3. So 3 goes there. Ooh, alright. Now those are also pairs. These have to be 2, 3. And those have to be 1, 9. And that is... I don't think that's resolvable. Yeah. Wow, that's weird. We've basically penciled out the entire grid at this point. I would have expected something to budge by now. Maybe it is this X code I'm looking at. Not really though, because the 8 here... No, it doesn't give us anything. Although I suppose, yeah, this can't be 2, 8. Because of this cell. If this is 2, 8, that leaves 1, 9 here. But that removes 1 and 9 from that cell. Which means which means that this can't be 2, 8. So now 2 is down here. Meaning that this has to be 1 and 9. Yeah, because we know 3 of the 4 digits here are 1, 2, and 9. And so this can only either be 1, 8 or 1, 9 or 2, 8, sorry. So this has to be 1, 9. And the 1 here disambiguates that. So this is now 2, 8. Which resolves a lot for us. This gives us a 5 here and a 2 there. 5 here resolves this 5, 7 pair. 1, 9 means this is now an 8, which resolves everything down here. The 1s here mean those are not 1s. 1 goes down there. Actually, 6, 7 pair resolves a lot of stuff. This must now be 8. That must now be 2. This is 6, which resolves this, which gives us that. Oh, wait a minute. Oh, wait, why did I say this is 2, 8? This is not 2, 8. It must contain a 2, but it doesn't have to be 2, 8. I'm just saying that this can't be 2, 8. Doesn't mean that this has to be 2, 8. Alright. That was a little mistake on my part, but everything should still be fine. Those in fact just form a pair of like 2 and 6, I believe. Alright, we're finally done. This is all just disambiguation steps. So 4 can't be there. 4 must be here. 9 resolves this 3, 9 pair, which goes ahead and resolves all of this. 2 means this is 1, 2, that must now be 9. 1, 6, 7 is resolved by this 6, which I'll eventually do. 2, 5, resolved by this 3, 5, this 3 resolves that. So 5, 3, this 5 means this is 2, 5, 2 means this is 6, 2, whoa, 2, 6 means this is 7, 6, and lastly, whoa, there we go. Solve the puzzle in 20 minutes and 17 seconds. Awesome. This one actually took a lot more deduction than I thought would be required. Although I guess that the puzzle was in fact rated at like 6 out of 10 for difficulty. Right, so I hope you enjoyed that video. I'll see you guys next time. Bye bye. Hello, this is Splat by James Sinclair. A puzzle from his Artisanal Sudoku volume 113. It is a pretty interesting looking puzzle, and I can tell why he calls it Splat. It's because this little cage here looks like if you threw something on the ground and it splat, you get like this random marks everywhere. But alright, let us take a look at the rules. So normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Killer cages. The digits cannot repeat within a cage. So here we have a huge killer cage. It is 9 cells large, and digits may not repeat in that cage. So something that looked like this is not allowed because those 2 digits are the same and in the same cage. Alright, next. Arrows. So the sum of digits along an arrow is equal to the digit in the connected circle. For example, those 2 digits, sum to whatever is in here. Those 3 digits sum to whatever is in here. Alright. Digits in cells separated by a white dot are consecutive, so those digits are consecutive, meaning one of them is one greater than the other, is what I meant to say. A bit hard to talk when I'm really talking this fast, but this is valid. Something like this would be valid, something like this would be valid. Black dots, digits separated by a black dot have a 1 to 2 ratio. So one digit is double the other. Something like this would be valid. This is valid. This is valid. Digits... Yeah, that's it. That's all the rules. Yes. Alright. So with that, let us just begin solving. Now, what do I want to start with? Let's start with the longest one. Those 3 digits are all different because they're in the same row, and sum to whatever digit is in here. Now, those digits are at least 1, 2, and 3 then, and that sums to 6. So this is at least 6, and is therefore either 6, 7, 8, or 9. What else can we do? Maybe the arrow with the dots on them. Yes, in fact, those arrows must sum to a multiple of 3. And the reason why is because, take a look at an arrow here. One of them is smaller than the other always, and let's say the smaller one is an x. The bigger one is then 2x, because it is double the smaller one. And therefore the sum of digits on touching the black dot would be x plus 2x, which is 3x. And therefore the sum is always going to be a multiple of 3. So those 2 digits in fact are always 3, 6, or 9. And in fact it's easy to tell how each of these are fulfilled. A 3 is with 1, 2, a 6 is with 2, 4, and a 9 is with 3, 6. And speaking of black dots, the 4 ways to make a black dot work are 1, 2, 2, 4, 4, 8, or 3, 6. And those are the only ways you can fulfill a black dot, meaning 5, 7, and 9 can never be on a black dot. Right, so that's all the simple deductions done. What now? Well, I suppose this cage cannot have repeated digits. So in fact, every one of those numbers are different. And therefore, well, yeah, none of those can be greater than 2. Or none of those can be smaller than 3, sorry. Because 1 and 2 cannot be fulfilled with, 2 arrows, with a 2-length arrow. Or a 3-length arrow for that matter, but we don't really need to talk about that. And what that means is that what was I trying to say? Sorry, I'm blanking out. What that means is that 1 and 2 must be in those cells, because it can't be on an arrow circle. Which might be useful. It does help us with this and say that this can't be 3, because this can't be 1 or 2 anymore. We already have 1 and 2 in the box. So this now can't be 3, it's either 6 or 9. And it can't be 9 either. There you go. It can't be 9, because if it was 9, that forms a very special type of contradiction. If this is 9... Oh, it doesn't. No, hold on. If this is 9, this is 3 and 6. This would be 3 and 6 because of the 9 here, and that will be fine. Because those digits can be the same. Right. Never mind then. Okay, what digit is this in the box? Because this digit cannot repeat in its cage, it can't be repeating in its column, it must be one of those cells. So can I mark that? Okay, the color is a bit darker here, but you can tell that those are all the same. And then we can also do that for this one by the same logic. Yeah, can I remove the color here? Is it still purple or pink? It's still pink. Okay. I don't use pink because this is already pink. So I'll use orange and blue. Yeah, really just placeholders for digits, but alright. Oh, that means that this can't be that small either. This is at least 3. If it was 6, it would need to be 2 and 4. And if it were 9, it would need to be 3 and 6. Now, because of the 2 here, we can remove 2 from this cell, and subsequently remove 4 from that cell. Now that could be a 3 though. If you put a 1, 2 here, those have to be 1 and 2. This could similarly be 4 or 6. Yeah, I don't see why not. Okay. And, even if... I guess it's either 3 in here or 4 in here, right? Yeah, it's either 3 in here or 4 in here. You can't have both 3 and 4 also be removed, because then you have 4 cells that are not in a circle, which doesn't work in this cage. So either you have 4 somewhere or 3 somewhere, and those two numbers are particularly interesting in terms of adding them, in terms of adding to them with 2 digits. If it's a 3, it's always 1 and 2, and if it's a 4, it's always 1 and 3. Now, I'm not exactly sure how that will be useful though. We also have 5, 6, 7, 8, and 9. And I can't actually say any digit is excluded from a circle besides 1 and 2, because it is entirely possible to arrange, I mean, from what I now know, it is entirely possible to arrange it in any way so that the missing digit could be anything. It could even be 9 if you tried hard enough. So yeah, and this digit does not need to be here, it could be whatever's in here, which could also be a pretty big number. Although this digit is very interesting. It is one of those digits, because this digit can't be in its box and can't be those digits by its row and column. So where does this digit go in the cage? It must be in one of those cells. Ooh, and that does tell us something. Does it? Because, no, this digit could be there, right? Well, I guess the, I guess it's a much easier thing to say that those 4 digits are those 4 digits. Because those 4 digits all cannot be in this cage, and therefore must be those digits in general, which are in fact quite large. Should be quite large because they are circles. Now, I don't see how, that would work though, because that doesn't really tell me much anymore. I suppose we could try talking about those digits, or in fact those digits. Wait a minute. Yeah, those digits are in fact where we go. Okay, because those digits are at least 1, 2, 3, 4, and 5. What that means is that those digits have to sum to at least 15. And to do that, those two digits have to sum to at least 15 as a result. But 15 is really big. The only way to make 15 in 2 cells is either with 6, 9 or 7, 8. Meaning that this can never be 3. There you go. And now 6, 9 pair here means that cannot be 6 or 9. That is 7 or 8. Which gives us a 1 in one of those 3 cells. If there was no 1 in those 3 cells, it would have to be at least 2, 3, and 4, which add to 9, which isn't possible. So this has to have a 1 in it somewhere. Now once again, 6, 9 here means that this has to either be 2, 4, or 3, 6. Although I guess we can't really tell right now. If this is 1, 2, 4 to make 7, then this could be 3, 6 to make 9, that's fine. If this is summing to 8, then this must sum to 9. Right, because those sum to at least 15, if this is 6, then this must be at least 9, which it cannot be. So this can't be 6 at all, meaning it is just 9. And to think about that is, another way to say is that if this is 7, this must be 9 from what I said. If this is 8, it's either 1, 3, 4 or 1, 2, 5. 1, 3, 4 doesn't work because it eliminates both possibilities from here. And 1, 3, 5... Wait a minute, 1, 3, 5... No, 1, 3... Oh, hold on. It's either 1, 2, 5 or 1, 3, 4. Right. And 1, 3, 4 removes both possibilities from this set, which means this must be 1, 2, 5, but that then forces this to be 3 and 6, which means this is always 9. So, either way you prove it, this has to be 9, and this has to be 6. I think the previous way I did it was better, where I said that, you know, because this must add at least 15, this can't be 6. Because this can't be 9. So yes. That gives us stuff. This must now be 2, 4, which must do this. This 9 must therefore be made of 3 and 6. This is therefore either 1, 2, 4 or 1, 2, 5, depending on what this is. So I guess we'll write that down. This is 1, 2, 4 or 5. I see. Okay, and now this digit is in one of those cells. It is either 4 or whatever this is. If it was a 4, it would be with 1, 3 here, which means that now can't be a 1. I don't see how that does anything though. I guess 9 is inside. 9 is no longer here or there, so 9 is one of those cells. Yeah, that's possible. Those cells do have to be fairly small, I guess. Yeah, and one of them must be a 4, right? Yeah, one of them must be a 4. There you go, okay. One of them must be a 4 because those digits cannot be 4. So one of them is a 4. Now, whichever one is the 4, it must be made of 1 and 3. And whichever is the 1 and 3 will look at this cell. So this cell can also never be a 1 in either case. Meaning you now have a 1-2 pair here. Sweet. Does that help us or not? I don't think it does. This cell could be there if 9 was here. That forces this to be 4 over here and those two cells to be the same. But I believe both are fine. Yeah, I believe both are fine. Can I tell what this is? I mean, I guess because of the 2, 4 here, this has to be at least 1, 3. Oh, that means there's at least 4. Fair enough. Where would 3 go in this box? Could 3 go in any of those cells? Yeah, those could both be 1 and 2. They can't both be 1 and 2, but they could be 1 and 2. Although, they have to sum to at least 10, right? Because 1, 2, 3, and 4 are at least 10 in total. So those digits have to sum to at least 10. Meaning if you had a 3 in there, it would need to be with 7 or 8. Which forms a triple, I guess. 3, 7, and 8 do form a triple. Which leave 5 and 4 to be out here. I mean, it looks fine at first glance. It looks fine. Yeah, it's fine, I believe. So then what? I guess 4 here would need to be with 7, right? No, it could be with 7 or 8. Ooh, hold on. Oh, never mind. This could be yet another number. Alright, well, okay. Because those digits have to sum to at least 10, they can't use 1 and 2. They have to use at least 3. Oh, they could be 5, 7, and 8 as well. They could have a 5 in them. I was saying they could have 3, 4, they could have 5. They can't have 6. They could have a lot more stuff in them though, so I don't think I see a satisfying way to solve this yet. I suppose this, I didn't really talk about it, but it must have a 1 and a 2 in some way. Because it's either 1 to 4 or 1 to 5. Now, where does 9 go in this row? This can't be 9 because of the column. This can't be 9 because of the cage. So 9 is one of those two cells. Is that useful? I don't see anything happening. The thunder is roaring. I don't know if you can hear the thunder. But there is a pretty heavy rain outside. So yikes. Alright. Let me just try and get cozy with this solving. I still don't see where to go though. I mean, those digits have to be fairly... one of them has to be like a could they contain a 3 and a 4? I guess that's the question. Could it contain a 3 and a 4? We know that those can't contain both 3 and 4 because you can't have 1s in both of those sets. But if this had a 1 in it, the other set here could have a 1 in it, right? So you could have 3, 4 here, you could have 3, 4 here. Although I guess this can't be 3 or 4. Which means that if there were 3 and 4 in the circles, they would have to be here and there. Which means what? I don't think I see anything here. Can I see what that could be? This can't be 1, 2, or 3 because 1, 2, and 3 are already elsewhere in the row. It can't be 4 by column. It can't be 6 or 9 by box. So it has to be 5, 7, or 8, right? That might help. Maybe it could help. I don't know. How would 5 be fulfilled? It could be anything. So it could be 1, 4. It could be 2, 3. 7 and 8 are basically the same problem. Yeah. I mean, where would... Oh, I was gonna say where would 6 go, but like 6 is right here. Where would 6 go? Maybe I have to use the dots or something. I haven't touched the white dots a single time. Like those can't contain 2, 3. It could be 4 and 5. It can't be 6. It could be 7 and 8. So if we look at that clearly, we have two options. We either have 4, 5, or 7, 8. Why is that useful? I don't see how that's useful. Okay. Oh, I see. Where does 3 go? 3 in this case. 3 must be with 4. It must. And that's because wherever 4 is, 3 must be in the arrow. Which means wherever 4 is, it's made of 1 and 3, which always stays in this box. Wow, so 3 can't be here. Because then none of those could be 1, 3 to make 4. And so 3 is actually none of those cells and must be here. So it's 3 with 4. Wow. So those digits are 1, 2, or 1, 3. Which gives us a lot to think about. Now this can't be 3, right? Because if it was... well, this could be 3 if you get 4, 3 here. I think. Yeah, so this could be 3. They're saying this digit is here. This digit could be one of those digits. If this is 4, that works. If it was 3, 3 could be here, this could be 4, this could be 9, and whatever this is. But that means that in this cage, the remaining digits are 5, 7, and 8, which form a triple. Now those digits have to sum to at least 10, because 1, 2, 3, and 4 are at least 10. So this digit can never be 5, because those digits can never sum to 10 or more that way. So this can't be 5. 5 in this cage must therefore be here. And now, with the 5, 6 here, those digits are actually pretty constrained. In fact, those digits can't be 5, 6, 7, or 8. Because 7, 8 here form a pair, both of which look at those two cells. 5 and 6 look at both of those cells. And because this is 7 or 8, this definitely can't be 9, because 9 plus something can never give you a lower number. So this can't be 5, 6, 7, 8, or 9. They have to be 1, 2, 3, or 4, which gives us a quadruple. That means these sum to exactly 10. And therefore these have to be 3 and 7, exactly. There is no other way to make them sum to 10. That is very cool. Whoa, look at that. And so 3 is 1 and 2, 4 is 1 and 3, 7, well, without the 1 and 2 you get 3 and 4, which do add to 7. 8 must be made of 1, 2, and 5, so there you go. This doesn't change much. The last 3 digits here are, I think, 4, 8, and 9. We know 9 isn't here. Yes, we know 8 isn't there. We know 4 and 8 aren't there because of those, so that has to be 9. Ooh. Meaning that digit is now a 7 to finish the column. 3 we know is not here, so 3 must be there. This forces 9 here, and the last digit here will be a 7. Cool. This forms a triple. They have to be 6, 7, 8, I believe. Right. So yeah, that was a pretty neat analysis of this entire mega structure in the middle. Yeah, I liked it a lot. I liked it was very slow, but the deductions were there and they weren't really that hard to spot. Alright, 4 is one of those cells. I guess the thing we have to do now is finishing up the entirety of the Sudoku, which probably involves those gauges. Let's start with this dot here. This 4 means this is either, well, if it was 8, it would need to be next to 7. If it were 4, it can't be next to 3, so it would have to be next to 5. So that gives us this. Maybe that? We now know that can't be... Ooh. That has to be 3, 6? No, it could be 2, 4, I think. It can't be 1 and 2 because those 3 digits are 1, 2, and 5, meaning that one of those has to be 1 or 2. If 1 and 2 are here, you can't make one of those digits a 5, which that would fail. So it can't be 1 and 2. It can't be 4, 8 because this would then have no option. It could be 2, 4. That is possible if 2 was out here and this was an 8. It could also be 3, 6. That's also fine. So yeah. Okay. Let's just mark those down in case we need them. This circle also here, this circle over here also gives us stuff. 3 has to be next to 2 or 4, but it can't be next to 4 because 4 is already in the box. So this 3 would be next to 2. 4 coming next to 3, it will have to be next to 5. So that gives us 2 or 5 here, which continues on this, but I don't know if that's productive or useful in any way. This could not be 1, 2. It could be 4, 5. If this was 7, 8, it could be 4, 5. It could be 7, 8, or 9. Yeah. So no, I don't think this is where we continue. Oh, 3 in this box must be one of those cells. That forms a 3, 4 pair. That forms a quadruple here. I don't think I want to mark that down, do I? Do I wish to mark that down? Probably not, but I can tell you where does 1 go in this box. It's in one of those cells, and all of them look at this cell here. So that can't be 1. That's 2. That's 1. This 2 means that can't be a 2. So 1 or a 5. But 2 is now one of those cells. That's very useful because this now can't be 2 or 4. It must be 3 and 6. That resolves stuff for us. 3, 4. 4 here means that's 3. 4 means this must be a 5. Does that do more stuff? 5 means this is a 1. That gives us this. 2 5 pair, 3 6 pair, 4 8 pair. All not resolved yet. Those form a triple, they have to be 2 6 and 8. 2 come in those cells, so 2 must be here. 6 8 pair is resolvable by this 3 6 pair here. 8 8, no. No. Alright, sorry, blanked out once again. I gotta focus, man. 2 is in one of those cells. I guess that's cool, because we know in this row 2 can't be here, and this 2 can't be here. Or I guess in this box 2 can't be here or there. If 2 was here, it would need to be next to either a 1 or a 3. It can't be next to 3, but it could be next to 1. So 2 could be there. I don't know if we have other possible options, but I don't think I want to explore them all right now. What else can we do? Alright, so I shifted my mic a bit, so I'm talking more into it. I realize I've been like leaning on the side and talking to the side of the mic, so I don't know if that's affecting the audio quality when you listen, if it's like only going in your left ear or something like that. But I shifted it so I can stare at the screen and also talking to the mic at the same time. Oh, I'm sorry, this is a lot of pairs. I don't know what I'm looking at. This is 4 and 5. Whoa. 4 and 5. I guess the one issue is that I can no longer press on my keyboard as efficiently. This is 6, 7 and 9. No, 6, 8 and 9, sorry. Okay, I mean that's not very useful because we don't have anything else in the bottom band of you know, rows. So we're not done just yet. Yeah, I don't see what else I have to look at, honestly. Maybe I do still consider what those are. It gives us more... Oh, okay, hold on, that's a triple. I should have seen that first. And in fact, this triple is 2, 5, 6, which removes 6 from that cell. Not sure how that helps, but this is now a triple. They have to be 7, 8, and 9. This digit can now be a 9. Does that do anything? Almost. This is now... Well, here we are missing 1 and 5, which have to be in here. So I guess I can try to work with that. 1 and 5 have to be there somewhere. Those digits? No. Maybe. I keep staring at this because I'm pretty sure this does something for us, although I'm not entirely certain on what it does. Because 2 could be next to 1. I mean, what could that be, honestly? I mean, let's just really try, okay? This could be 1, 2, 7 or 9. Does that break? 1 can't be next to 2 because this can't be 2, so this can't be 1. 2 could be next to 1, that's fine. 7 is either next to 6 or 8. It can't be next to 6, so 7 would be next to 8. Ooh, and 9 would need to be next to 8 as well, so this is only 1 or 8. Oh, interesting. Okay, I mean that was probably helpful to figure out. This is either 1 or 8. That is only 2 options, which is a lot more useful than usual. I mean that doesn't form any useful pairs here, but... yeah. Okay, 5 now has to be one of those cells. Can we do the same for anything else? 4 and 8, no. 3 and 6, no. Whatever this is has to be here as well, because it can't be in any of those cells. It could also be a 1. This could also be a 1. Actually, could it? I don't know. What am I not seeing? I'm sure there's something I'm not seeing. I don't see what. So, keep talking about seeing stuff, obviously. But no, the numbers are just floating around right now. Yeah. What the? What? What's going on? Are there any more like quadruples I could just fish around for? I suppose 5 is in one of those cells. 7 here would force a 7 up there. Whatever this digit is, well, we don't know what it is at all. It could be a 5, which is down there. It can't be a 2. It could be like a 1, which forces 1 up here. Hmm. Four, 5, no. But 7, 8 here means this has to be 1, 2. Which might be interesting. That leaves what? 9, 4, 5? Ooh, that doesn't work, does it? It just doesn't work. Alright. Okay, let's see how I can more properly explain this. 4 and 5 here imply that in this box, 4 and 5 must be in one of those 3 cells. There you go. Therefore, either 4 is in here or 5 is in here. You can't have them both be outside the dot. So either 4 is in here or 5 is in here, and therefore this has to be 4, 5 and cannot be 7, 8. That's how you explain it well. So now that's 4, 5. 4 means that's 8. Which now means 8 is in one of those cells. This now can't be 5. Okay. What else can we do? This 8 removes 8 from there, but I don't expect that to do anything. This being 4, 5 implies that this could still be a lot of stuff. But my main reason for figuring out this is 4, 5 is by saying that if this is a 7, then this is 8, and then it causes a whole bunch of implications. But no, that's not right. I mean, I guess because 4 and 5 are here, 3 and 6 are in here, then because those 6 digits are equal to those 6 digits, right? Those are both sets 1 to 9 without those 3 digits. Then those digits are the same as those digits. Meaning that whatever's in here must be in here. Now, I don't know if that's important, or if I'm just chasing something that isn't very useful at all. It's like, I think this is a 1, 7, or an 8. Yeah, that's a 1, 7, or an 8, although I don't think that's useful. Should I use a different color for this? I'll leave it. Okay, what else do we have? 4 is in one of those cells, which doesn't do anything for us. No, it doesn't. 8 is in one of those cells, so I guess 9 can't be in those cells, but 9 could be anywhere else. This set could be a bunch of stuff. It could be 1 and 2. It could be 4, 5, 5, 6. It could be 8 or 9. It could be 8 and 9. Sorry. How do we distinguish which one it actually is? I'm not sure if we can. I suppose it is fairly interesting to think about what happens if some numbers were some numbers. But I don't think it's, I ultimately don't think it's very, you know, like if this digit was a 7 or a 9, then that would be here. That would, ooh, hold on. If this was 7 or 9, oh no, this could be the other one. I was like, if this is 7 or 9, then this is 7 or 9, but then this could be the other one of 7 or 9, which in fact it has to be, because this has to be 8 as a result. So 1 and 2 will be here. I mean, otherwise, if this is an 8, then this is 1, this is 2, this is a 1. So I guess this is 1, 7, or 9. Yeah, because this forms a quadruple, right? This is a 1, 2, 7, 9 quadruple. So I guess we'll just do that. I'll bite the bullet and do that. This, because 2 is in one of those cells can't be 2. Cannot be 2. That gives us that. Which, this can't be 9, I guess. So that's 1 or 7. But then what? But then what indeed? I don't want to start doing all of this all over again. Like this over here, I think like, oh, there can't be 1, 2 definitely because of the 1, 2 in that cell. It could still be 2, 4, it could be 4, 8, it could be 3, 6. I think it could be anything. Well, it clearly can't be 3, 6. Ooh. Yeah, that's interesting. It can't be 3, 6. Because there's a 3 in here, there's a 3 in here. So 3 in this box, 3 in this column actually. Where does 3 go? 3 can't be in those cells, it can't be there. So 3 is in one of those cells. That's why this can't be 3, 6. But it also can't be 1 or 2 because that would remove 1 and 2 from those cells. So now it's either 2, 4 or 4, 8, which means it must have a 4 in it somewhere. That disambiguates that cell. That's a 5. 5 in terms of number. That's a 4. That could lead us somewhere. Like 4 in this box is now in one of those cells. Maybe not. Maybe it's still not as useful as I imagined it to be. 6 now. Well, I suppose 6 in this column, because 6 is one of those cells, right? From this row. 6 can't be there, so 6 is one of those cells. I don't really see the point to that. We have 1, 3, 6, and we haven't talked about 8 in this column yet, but 8 I think could be in any of those cells. So yeah, I guess if this was 4, 8, then 8 is here. But that's not really something that we should be considering until later. This could be anything. No, actually, it can only be 1, 7, 8, or 9. because it can't be 2. We know 2 is in one of those cells. But that's still a lot of digits and very few, you know, stuff. Oh, well, okay, hold on. Where does 3 go in this column? 3 is in a pair here and is in a pair here, so it can't be in those cells. 3 can't be there, so 3 is in here. And 3 is actually with beside a white dot. So it needs to be a consecutive digit. But 3 can't be with 4. It must therefore be with 2. There you go. That should help us a lot because this is now resolved. I don't know if that gives us more. This also resolves that. That can't be 2, so that's 6. Yep, there you go. This is now 1, 7, 8, 9. But I don't see what that could possibly mean. 8. No. 6. No. Okay, how does that help us? I guess, yes, this actually forms an X-wing. They must have 2 in them somewhere. And so let's think about where 2 goes in this row. It cannot be here or there. This 2 actually is removed from that cell. So 2 is in one of those cells. This now cannot have a 2 in it. It must be 4, 8. Which now means that where does 8 go in this column? 8 must be here. Oh, okay. We're getting somewhere. 8 in this row must be there. Because this can't be 8. That forms a 1-5 pair here. This 4-8 pair means that can't be 8 anymore. 2 in here must be with something, but can't be with 3, so 2 must be with 1. That helps us because that forms another X-wing. Where does 1 go in this column? It can't be in those cells because of 1-2 pair. That must be 1. Ooh, and that gives us a lot of stuff. Those can't be there anymore. This 8 means that can't be 8. Okay. And now, this digit can't be 1. So that's 7 or 9. What do we do then? I feel like we're getting close to the end already. Like, very, very close. 8 is resolving this over here. Which resolves this over here. Which resolves this up here. Ooh. Which should resolve small stuff, okay. 7 resolves maybe? Not really. It kind of halts right here. Comes to a halt. Whatever that would mean. Yeah, that is all very dependent on what those cells are. But I guess this is a triple. What is this? 3, 6, 7? Oh, not 2. So this can't be 3 or 7, so that's 6. Oh, this forms a pair. They have to be 5 and 9. Which unfortunately is still not resolvable. Okay. This can't be 6 anymore. This can't be 9, so that forms a chocolate teapot. Very lovely. No, we should be able to do more stuff here. 8. 8 is in one of those cells, which makes sense, I suppose. 5 is in one of those cells. 5 could be here with 6, I think. Can't be here with 4 because 4 is outside of it. But it could be with 6. Alright. I suppose we can talk about where 1 goes in here. Because of the 1-2 pair, 1 can't be there. 1 can't be on the dot either because 1 will have to be next to 2 to make a consecutive pair. The 2 is already in the column. So 1 can't be next to the dot, meaning 1 is in one of those cells. Which means this now can't be a 1. That's 3. And this resolves the 3-6 pair up here. Oh, 3 in the corner. Awesome. 6 now. Yeah, 6 now in this box has to be here. In there. It could be with 7 or 5 though. So I guess I'll put that in 5, 6, or 7. No, I don't really. This could be 5. 5, 4, 8, 1. That's also possible. This is a triple. It have to be 1, 7, and 9. This can't be 1 or 7 because of the pair here. So this must just be 9. That resolves a whole lot. This now can't be a 7, which means 7 in here must be there. 8 must be consecutive to something, and it can't be consecutive to 2, so it must be 9. Wait, what? Oh yeah, because it's 7. Why did I put a 9 there? I don't know why. Alright, 9 resolves this, which resolves this 1 5 up here, which resolves this 1 2 over there. There you go, all resolved, all fixed, maybe. Those digits are now 4 and 9. That works. 9 resolves this entire thing, so that's 8. That is 6, that is 9. 6 now can't be there, so that helps us because 6 can only be here now. Those digits have to be something. 8 can't be there. So 8 goes down here, which forces 1 down here. That resolves everything actually. 2 means that's 3, that's 2. This 3 means that is 7, that is 3. 5 means this must not be 7. So those digits have to be 4 and 5. This resolves that. 4, 5. 4 means that is 9, that's 4. 9 means this is 7, this is 9. Nice, solved the puzzle in 45 minutes and 9 seconds. Awesome puzzle. Well, I hope you enjoyed this puzzle. I'll see you guys next time. Bye bye.